My name is Mark. Welcome to our Module 4, My Carbon Footprint. Within the 5 lessons of this module, you will learn how to calculate your own carbon footprint and learn the simple changes you can make to reduce your impact on our Earth. I myself have managed to reduce my footprint within 1 year by over 70% once I knew what changes to make. In doing so, I also saved a lot of money and now live a more sustainable and greener lifestyle. At the end of this module, you will know how to calculate your own carbon footprint for the years to come, as well as being able to help others to calculate their footprint. Let me start by letting you in on a little secret. It's very easy once you know how. It was Sir George Porter that once said, "If sunbeams were weapons of war, we would have had solar energy long ago." A carbon footprint measures the total greenhouse gas emissions caused directly or indirectly by a person, or an event such as the FIFA World Cup Soccer, an organization like ourselves, or even a product like a packet of peanuts. Results are best measured in tons of carbon dioxide equivalent. A carbon footprint is almost always calculated for a period of 1 year. It need not be a calendar year. It could, for instance, be from the 1st of July until the 30th of June the next year. You can work out the footprint for an individual, a household, a company, a product, an event, or even a city like Cape Town or Amsterdam. The final result that is calculated during this exercise is the total amount of greenhouse gases emitted by all activities in what you are measuring. In this module, we will calculate your and my individual carbon footprints over a period of 1 year. These amounts are then converted into carbon dioxide equivalents. So as an example, my carbon footprint for the year 2008 could be 40 tons of carbon dioxide. At the end of lesson 5, we will let you download from our website your own certificate that I will help you fill in. This certificate will have your name, a photo, your address, the start and end dates of your carbon footprint calculation, as well as the total amount of CO2 equivalent greenhouse gases you emitted. Imagine your family and friends' surprise when you present them with your own carbon footprint certificate, showing that you care about your planet and that you are making a difference. The whole idea behind this exercise is to measure, then to implement methods to reduce, and then to remeasure to calculate the amount by which you have managed to reduce, thereby collectively helping us to bring the parts per million of greenhouse gases in our atmosphere back to the ideal of 350. I would like to share with you a very important news item that shows South Africa's commitment to climate change and making the necessary changes to reduce our emissions as a country. South Africa's Water and Environmental Affairs Minister, Vuyelwa Sonjika, announced on Thursday, the 21st of October 2010, South Africa plans to address the impact of climate change by reducing carbon emissions by at least 43% in the next decade, while a series of strict measures will also be put in place to avert pollution by the country's mines. As part of the agreement, Sonjika, together with provincial MECs responsible for the environment, as well as other stakeholders in the delivery chain of government, undertook to prepare strategies to help South Africa cope with the imminent climate change impacts and reverse the rising trends related to pollution and ensure proper and better management of the environment. South Africa is ranked amongst the top 20 greenhouse gas emitters, and it is the highest emitter within Africa. I would like to start by explaining some of the fundamentals to you so that you can fully understand how carbon footprinting works. For those of you who are knowledgeable on the subject of carbon and footprinting, I ask you to please be patient while I explain the basics to those who are watching and are quite new to this. You can see this as a quick refresher, and who knows, You might even learn one or two things you did not know before. What is this carbon that everyone is talking about? Well, carbon is the chemical basis of all known life. It is the fourth most abundant chemical element in the universe by mass, after hydrogen, helium, and oxygen. Carbon is abundant in the sun, stars, comets, and in the atmosphere of most planets. Now, in terms of carbon footprints, the carbon that is mentioned is actually carbon dioxide, which has the chemical formula CO2. It is a chemical compound composed of two oxygen atoms bounded by a single carbon atom. In combination with oxygen in carbon dioxide, carbon is found in the Earth's atmosphere and dissolved in all water bodies. Hydrocarbons, such as coal, petroleum, natural gas, also contain carbon. The amount of carbon on Earth is effectively constant. Thus, processes that use carbon must obtain it somewhere and dispose of it somewhere else. The paths that carbon follows in the environment make up the carbon cycle. For example, plants draw carbon dioxide out of their environment and use it to build biomass. Some of this biomass is eaten by animals, whereas some carbon is exhaled by animals as carbon dioxide. The carbon cycle is considerably more complicated than this short loop. For example, some carbon dioxide is dissolved in the oceans. Dead plant or animal matter may become petroleum or coal, which can burn with the release of carbon, should bacteria not consume it. Around our planet, there is a layer of gases called the atmosphere. When the rays of the sun come through the atmosphere and strike the surface of the Earth, some of these rays reflect back. A few of these gases, collectively known as greenhouse gases, prevent these rays from leaving the atmosphere. This is known as the albedo effect, and this creates a warming effect on Earth, known as global warming. There are a few of these greenhouse gases, but the most common ones, in order of abundance, are water vapor, carbon dioxide, methane, nitrous oxide, ozone, and CFCs. Some of these gases can stay in our atmosphere for up to 100 years. It is important to know that these greenhouse gases are necessary to keep our planet at comfortable temperatures for humans, plants, and animals to survive. If it gets too hot or too cold, the Earth can become uninhabitable for most species. Our atmosphere contains roughly 78.09% nitrogen, 20.95% oxygen, around 0.247% water vapor, 0.038% carbon dioxide, and traces of hydrogen, helium, and other gases. Water vapor accounts for the largest percentage of the greenhouse effect, between 36 and 66% for clear sky conditions, and between 66 and 85% when including clouds. Water vapor concentrations fluctuate regionally, but human activities do not significantly affect water vapor concentrations, except at local scales, such as near irrigation fields. As you can see, the gases that contribute to global warming, excluding water vapor, due to the fact that we as humans have no control over this, only makes up less than 0.04% of all the gases in the atmosphere. This tells us that there is a very delicate balance, and our continuous burning of fossil fuels like coal for electricity and converting oil to petrol and diesel for our engines can quickly lead to an excess of these gases in our atmosphere. Let's now discuss all greenhouse gases and where they come from. Water vapor is produced in the natural water cycle and stored in clouds, as well as from man-made sources such as aeroplanes. Carbon dioxide is released mainly from the burning of fossil fuels, such as coal and oil. Methane and nitrous oxide are also released from the same thing, but this is dependent on the mode of burning the fuel. The main sources of methane is from livestock agriculture. Nitrous oxide is mainly released from artificial soil fertilization or inorganic composting. Sulfur hexafluoride is mainly released from leakages in electrical substations. CFCs are mainly leaked through refrigerant and cooling gases and other specialized industrial processes. The contribution to the greenhouse effect by a gas is affected by both the characteristics of the gas and its abundance. For example, on a molecule-for-molecule basis, methane is a much stronger greenhouse gas than carbon dioxide, but it is present in much smaller concentrations, so that its total contribution is smaller. Due to this, it was decided to convert all greenhouse gases to a single unit of measure for ease of calculation. This unit is carbon dioxide, as it is the most abundant greenhouse gas in the atmosphere after water vapor. Here you will see the conversion table that is used to convert the remaining gases into their carbon dioxide equivalents. You will notice from this table that releasing 1 kilogram of CFCs into the atmosphere has a much higher warming potential than, for instance, methane. NASA scientist James E. Hansen's 2007 paper stated that 350 parts per million, or ppm, of CO2 in the atmosphere is a safe upper limit to avoid a climate tipping point. In other words, a point of an uncertain future in terms of climate. The current record level is 392.04 parts per minute of CO2, an almost 40% increase from the pre-industrial revolution levels of 278 ppm. In 1998, the Earth's atmosphere surpassed the 350 ppm mark, while global CO2 emissions continue to rise. So this talk about going green, global warming and climate change, just to mention a few, is all about everyone working together to bring the carbon dioxide in the Earth's atmosphere back to under 350 parts per million as it was in 1988. Nothing more, nothing less. There has been a lot of investigation into the effects of global warming, and various experiments have been carried out to attempt to replicate what would happen if the temperatures around the world were to increase by 2, by 4, or even 6 degrees Celsius. If this were to happen, then the frozen water held as ice around the mountain peaks and the polar regions would melt. The result of this would be that sea levels will rise and many of our coastal cities would be underwater. This process has already begun. Snow-covered mountains have in the last decade been severely affected by the recent rise in temperatures. Another serious effect of global warming is climate change. Not necessarily that the climate is getting warmer, but that it gets colder sometimes too. The imbalance of gases in our atmosphere, caused by you and I and everyone else, has led to the weather doing unpredictable things. In the last 5 years alone, there have been conditions never experienced before. Violent storms, tropical cyclones, tsunamis, hurricanes like Katrina in North America, heat waves and flooding, as well as droughts. I would also like to mention that many huge oil spills that damage our seas and coastlines every year just to bring oil for petrol to our vehicles. And this is only the beginning. Things are set to get far worse unless we act now. So let's all act together, spread the word, and do our bit. Carbon neutral is a term that we are beginning to hear more and more about each and every day. But what does it mean? If you calculate that your carbon footprint for the year is 40 tons of CO2 equivalent, for instance, and that you manage to reduce your footprint to 30 tons, then you need to offset the balance of 10 tons to become carbon neutral. It's good to remember that any activity that leads to the absorption of carbon dioxide is a step in a positive direction. One of the ways to do this is to plant trees, as they will soak up carbon if the tree is allowed to grow for at least 30 to 100 years. Take note here that some trees take up much more carbon on a yearly basis than others. In other words, not all trees soak up at the same rate. That means that you cannot plant just any tree. You need to investigate which tree soaks up a lot of carbon and then plant those trees. The spekboom has the capacity to offset harmful carbon emissions, equivalent to that of a moist subtropical forest. This is quite incredible. Evidence gathered in the Eastern Cape over the past 7 years shows that speckboom has enormous carbon storing capabilities. It's an indigenous plant known as elephant's food, and it shows potential to mop up the excess CO2 responsible for climate change and make a fortune for South Africa on the international carbon trading market. Another way to offset your emissions is to buy carbon credits, but we will explain this in much more detail later on in our training courses. Now we are going to take a look at some of our daily activities and how they relate to the increase of these greenhouse gases. Every time we turn on a light or the television in our home, we are directly responsible for releasing these gases into our atmosphere. You see, most electricity producing power stations around the world do so by burning large amounts of coal. In this illustration, you can see the process. And in this next picture, you can see the devastating effects they have on our atmosphere. The same goes for cars and aeroplanes. An alternative to this method of producing electricity from coal is to produce it from renewable energy, such as sun, from the wind, or by the movement of the oceans. Batteries are charged, and the stored electricity is then converted to power our homes and businesses. And an alternative to using petrol or diesel for transportation is to use electric cars or buses and to charge these batteries by harnessing the energy from renewable energy. There are also large organizations around the world using ethanol or biodiesel to power engines in cars and buses. Some of the big airlines have already been experimenting with renewable energy to power their aircraft. So in essence, the whole world is seriously concerned about global warming, and so should you and I be. And I must add that the only way to reduce is to measure, reduce, and then to remeasure. That is why it is so important for you to complete this course and to know how big your impact on Earth is. And then to spread the word to get everyone you know to reduce their impact too. In our second lesson, we'll be discussing who is doing a carbon footprint and why. And in lesson 3, how you go about collecting the data needed to calculate your footprint. In the 4th lesson, we will calculate your actual carbon footprint and then transfer the total to your certificate in lesson 5. We will also give you a few tips to help you to reduce your newly calculated footprint. Now we come to the homework portion of this lesson. We would like you to download the zip file with the related articles to this lesson, and then read all the documents and take a good look at all the pictures. We look forward to seeing you again in lesson 2, where we will go into more detail regarding who is doing their carbon footprint and why they are doing it. Until the next lesson, happy reading.